Hello there, Mr. Sutton bringing you the AB Calculus 5-1 homework solutions on basic antiderivatives. For number 1, we're trying to find the antiderivative of 2 dx. So basically, what do I have to take the derivative of to get 2? Well, 2x plus a constant. For number 2, I want the antiderivative of x. So I'm going to need to raise the exponent by 1. That'll give me x squared. And then dividing by the new exponent of 2, I've got 1/2 x squared plus c. For number 3, we want the antiderivative of x squared. So we bump that exponent up to a 3, divide by 3, that gives us 1/3 x cubed, and then we have that plus c. For number 4, we want the antiderivative of 6x cubed. So that exponent needs to become a 4, and then dividing by 4, we have 6 over 4, or 3/2 x to the 4th, plus c. For number 5, we're finding the antiderivative of this polynomial, so we're going to go term by term using the reverse power rule. For our first one, we bump the exponent up to a 3 and divide by 3, so that's going to be 1/9 x to the 3rd. Next one, this becomes x squared. Dividing by the new exponent, we have 1/4 x squared, and then we have that plus c at the end. For number 6, we're finding the antiderivative of this polynomial. Going term by term, we've got 5x, and then this bumps up to a 2 for the exponent. Dividing by 2, we just have negative 1x to the 2nd power. Here, this bumps up to a 3 for the exponent. Dividing by 3, we have 6 over 3, or 2x cubed. And don't forget the plus c. For number 7, we're going to go term by term with the reverse power rule on this antiderivative. So we've got x to the 3rd now. We've got to bump that up to a 3. Dividing by the 3, we have 1/3 x cubed. And then this will become x to the 2nd. Dividing by 2, we've got negative 3/2 x squared. And finally, this will become 5x, and we have a plus c. For number 8, we want the antiderivative of 3/2 radical x. To make my life a little easier, I'm going to write this in exponential form, so 3/2 x to the 1/2 power. Now, using my reverse power rule, I'm going to bump this up by 1, so that'll become 3/2 for the exponent. And then if we divide by that, or multiply by the reciprocal, 2/3 times 3/2 is going to come out to 1. So that's just going to be 1x to the 3/2 plus c. For number 9, I'm trying to find the antiderivative of this crazy reciprocal radical function. To make my life a little easier, I'm going to rewrite this with an exponent. So this is really 1/3 times x to the negative 2 over 3. Now if I bump that exponent up, that's going to become a positive 1/3. If I divide by positive 1/3, well, 1/3 over itself just goes away. So then we just have x to the 1/3 plus c. For number 10, I'm trying to find the antiderivative of this function. To make my life easier, let's write this in exponential form. So this will be 2/3 x to the negative 1 over 3. We have the power divided by the root. And now I have to bump this up by 1, so this becomes positive 2/3 as an exponent. Dividing by 2/3, that cancels our coefficient out, so we just have x to the 2/3 plus c. For number 11, I need the antiderivative of this rational function. I'm going to rewrite these with negative exponents just so it's a little easier to use my reverse power rule. So we've got x to the negative 2 minus 2x to the negative 3. All right, reverse power rule. For our first one, we're bumping this up by 1, so the new exponent is a negative 1. Dividing by negative 1, we have negative x to the negative 1. Over here, I'm bumping this up to a negative 2. Dividing by negative 2, that cancels this out, so we just have plus x to the negative 2. And don't forget your plus constant. For number 12, I need the antiderivative of 1/x cubed. I'm going to write this as x to the negative 3, so then I can easily use my reverse power rule on this. So I'm going to bump my exponent up to a negative 2. Dividing by negative 2, that's going to be negative 1/2 x to the negative 2. And then we have the plus c. For number 13, I want the antiderivative of sine of x. Now, the derivative of cosine would be negative sine, so I need to do negative cosine for the antiderivative on this. So we'll have negative cosine and then plus c. For number 14, we just want the antiderivative of secant squared of x. So that comes directly out to tan of x because the derivative of tan is secant squared, and then that'll be a plus c. For 15, we want the antiderivative of 2 over radical 1 minus x squared. This looks a little tricky if you don't remember some of your derivatives of your arc functions. The derivative of arc sine is 1 over radical x minus 1 minus x squared. So the antiderivative of this then is just going to be 2 arc sine plus c. For number 16, we're taking the antiderivative of 4 over this mess down here. Now this is a little bit easier if you remember that the derivative of arc secant is 1 over absolute value of x times square root of x squared minus 1. So this is really just 4/3 times the derivative of arc secant. So the antiderivative then will be 4/3 arc secant plus c. For 17, we want the antiderivative of negative cosecant x cotan of x dx. On this one, we know that this is actually the derivative of cosecant of x, so the antiderivative of this is just cosecant of x plus c. For 18, we want antiderivative of 5 secant t tan t. We know that secant tan is the derivative of secant, so antiderivative of this then will be 5 secant of t plus c. For number 19, the antiderivative of 2 over x, we know that 1 over x is the derivative of ln of x. So the antiderivative of this then is going to be 2 ln of x. And don't forget your absolute value when you do that, because ln can't have negative numbers plugged in. And if you don't know what you're plugging in, then you have to leave the absolute value there for safety reasons. And then don't forget the plus c either. For number 20, we want the antiderivative of negative 1 over 4x. If we wanted to, we could rewrite this as negative 1/4 times 1 over x. So then this would be negative 1/4 ln of absolute value of x for the antiderivative, plus a c. For 21, we want the antiderivative of 21 e to the x. Funny how that worked out. E to the x is its own antiderivative and derivative. It goes both ways. So this is just going to be 21 e to the x plus c. For 22, we want the antiderivative of this cubic expression. So we're going to go term by term with the reverse power rule. Bumping that first exponent up, we've got the 4th power, and dividing by 4, we have 1/4 x to the 4th. Next, bumping the next exponent up becomes a 2. Dividing by that, we'll have negative 3 over 2 x squared. And then don't forget your plus c. So that's going to match answer choice, let's see, right here. Choice, nope, yeah, choice E. For 23, I want the antiderivative of 1 over x squared. I'm going to rewrite that as x to the negative 2. And if I use my reverse power rule, let's bump that exponent up to a negative 1 and divide by negative 1. That'll give me negative x to the negative 1 plus c. Matching the answer choice, be careful. C and D look pretty similar, but it's D that we need at the end of this one. For number 24, this one's a little bit tricky until you realize that 1 over 1 plus x squared is really just the derivative of arctan. So we can take a 5 out of this integral here. And then if we do it this way, we've just got 5 times arctan plus c. So let's see, that's going to be choice D. The others didn't even have an arctan in them. For 25, we just want the antiderivative of secant tan of x. So this is just the derivative of secant, so antiderivative will just be secant plus c, and that'll be answer choice A. For 26, we need the antiderivative of this expression. We're going to go term by term here. So this first one's a little bit tricky. We need antiderivative of 2 to the t. So I know if I took the derivative of 2 to the t, I would get a 2 to the t times an ln of 2. So to go backwards, I need 2 to the t divided by ln of 2. That way, if I took the derivative of all this, I would be multiplying by an ln of 2 and canceling those out. Next, e to the pi is kind of weird. The key on this one is recognizing that pi, e to the pi itself actually, is a constant, not a variable. So with constants, remember, we just put the variable of integration, t in this case, next to them. And then we'd also have a plus c. So this is going to give us answer choice B. For 27, we're given the second derivative of 2x minus cosine of x, so which could be the original function f. Since we're given the double derivative, we need to go backwards twice, take two antiderivatives. Let's do that now. So antiderivative of the original double derivative here, that's going to be bump the exponent up to 2, divide by 2, so x squared. And then this is going to be negative sine of x plus c. Now we need the antiderivative of this expression. This is really some form of the first derivative of the original function. So one more antiderivative. Bump our exponent up. That's the third. Divide by 3, we have 1/3 x to the third power. And then this will be plus cosine, because derivative of cosine is negative sine. And this plus c, it's a constant, so I'll just stick an x next to it. And we need another constant now because we took another antiderivative, so I'll call that plus k. Give it whatever letter you want. So we need to find an answer choice that matches this form. So we have an x cubed over 3. That narrows it down to choices A and B. We have a plus cosine, so that actually just narrows it down to choice A. And if we look at the rest of this, minus x and plus 1, I mean, it's kind of hard to match the form here, but that just means that c could be negative and k could be a value of 1. So choice A, by process of elimination, is the best one here. On this problem, we're trying to find the antiderivative of 2 to the x dx. So one way to do this is by using this formula when you have b to the x dx in general. That's just going to be b to the x over ln of b plus c. Another way you could have done it is just start differentiating the answer choices until you get 2 to the x. If you try that with a, you'll get 2 to the x ln of 2, and that's at that point you might realize, well, hey, I actually need a divided by ln of 2 to cancel out the ln of 2 that I get when I differentiate 2 to the x. Either way, this is going to come out to 2 to the x over ln of 2, answer choice C.